Way 53 talks about how the intermolecular forces within a substance can affect the boiling point or the melting point. In general, this term of intermolecular attractive force is said so frequently in chemistry that there's an acronym for it. It's called IMAF, IMAF, intermolecular attractive force. And you can think of this as the glue that holds a substance together on the molecular level. So think about this. If you have a substance that's trying to boil, we need to give it energy. Now, in order for that energy to boil, those bonds that occur between molecules, which we call intermolecular attractive forces, need to be overcome in order to become a vapor. So if you have this liquid with strong intermolecular attractive forces, it's going to have a high boiling point and a high melting point. Why? Because it's going to take more energy to break these forces of attraction between molecules in order to produce a vapor. If you have a substance with weak intermolecular attractive forces, it's going to have a low boiling point and a low melting point. Because if it takes virtually little energy to break these forces of attraction, you're going to be able to boil it a lot more quickly compared to those with strong intermolecular attractive forces. So when it comes to these problems, remember, if a substance has a strong IMAF, it's going to have a high boiling point and a high melting point. If it has weak IMAFs, it's going to have low boiling point, low melting point, because it takes less energy to break those forces. Let's try some problems. Organic compounds that are essentially nonpolar and exhibit weak intermolecular forces have Remember, if you have weak intermolecular forces, you're going to have a low melting point, meaning it takes very little energy in order to break the bonds existing within that substance and therefore will melt quite easily. And this is actually true for a lot of nonpolar substances. Many of the substances that exist at many nonpolar substances exist actually as liquids because the attractive forces between the molecules is so weak that it won't stay as a solid. Diethyl ether is used as a laboratory and industrial solvent. The boiling point of diethyl ether at standard pressure is 34.6 degrees Celsius. The equation below represents a reaction that produces diethyl ether. So you have two molecules in water with the addition of a catalyst producing diethyl ether. It says, explain in terms of the strength of intermolecular forces why the boiling point of diethyl ether at standard pressure is lower than the boiling point of water at standard pressure. So you must mention in your answer something about the strength of intermolecular forces between diethyl ether versus water. Remember that the stronger the IMAF, the higher the boiling point. The weaker the IMAF, the lower the boiling point. So if diethyl ether has a lower boiling point, that means its IMAF is relatively weaker compared to the IMAF of water. So you should mention something like diethyl ether has weaker intermolecular forces of attraction compared to water, or water has a stronger intermolecular forces, or water has stronger intermolecular forces due to hydrogen bonding. Remember, hydrogen bonding is one of those intermolecular forces that we'll discuss in future ways. Next question. In industry, ethanol is primarily produced by two different reactions. One process involves the reaction of glucose in the presence of an enzyme that acts as a catalyst. The equation below represents this reaction, so it says glucose plus an enzyme will produce ethanol. In another reaction, ethanol is produced from ethene and water. The equation below represents the reaction in which H2SO4 is a catalyst. So here you have ethene being added to water plus H2SO4 produces ethanol. Industrial ethanol can be oxidized using a catalyst to produce ethanal. The equation representing this oxidation is shown below. It says, explain in terms of intermolecular forces why ethanol has a much higher boiling point than ethene at standard pressure. If a substance has a higher boiling point, it means its IMAFs are stronger compared to the substance with the lower boiling point. So your answer should include something about intermolecular forces. Intermolecular forces for ethanol should be stronger if its boiling point is higher. You could also say that the boiling point of ethene is lower because the intermolecular forces are weaker than the intermolecular forces in the alcohol. You might also state something about hydrogen bonding. The alcohol functional group, OH, allows for hydrogen bonding between ethanol molecules. So ethanol has a higher boiling point than ethene. Basically, the bonding that exists between the molecules is so strong that it takes so much energy to boil ethanol compared to ethene. Which substance in the table below has the strongest intermolecular forces? Please note that for this table, it gives you 4 substances, their molar mass, as well as their boiling point. Now, you should be able to reason that the higher the boiling point, the stronger the IMAF. So, which substance has the strongest intermolecular forces? Well, it has to be HF because its boiling point is highest among all the 4 substances. Okay, so when it comes to evaluating which substance is going to have higher boiling points, it's going to be the one with stronger intermolecular attractive forces, or IMAFs. Please don't write IMAF on the reagents. Please write intermolecular attractive force. It's strictly an acronym that's just used so frequently that you should be able to remember what it stands for. Basically, the higher the boiling point or the higher the melting point, the stronger the intermolecular attractive force, and vice versa. The weaker the intermolecular attractive forces are, the lower the boiling point, the lower the melting point. Thank you for watching.